Hello everyone. I hope you all are doing well. Welcome back to my YouTube channel. As you all know, the CBSE board has made many changes in the question paper pattern. They are now focusing more on application based and concept based questions. This means students who are very clear with the concepts, they can score easily well in their exam. You have already experienced this in the mathematics paper. Most of the questions were competency based and concept oriented. So in today's video, I'm going to solve the most expected questions. And all these questions are strictly based on competency level. That is concept based questions. So don't skip the video. Watch till the end. Okay. In yesterday's class, we discussed about slide projector, right? In the slide projector, which type of the lens is used? That is convex lens. Now in today's class we are discussing about a DSLR camera. So students, please understand one very important point here. The CBSE board has changed its question paper pattern. Now they are asking competency based questions. Earlier they directly picking the questions from NCERT textbook. So you learned application of convex lens and concave lens from the textbook. But here, they are not asking any direct question. What is the application of convex lens? What are the application of concave lens? So they are asking questions based on that application. Okay. Instead of asking what are the application of concave lens, they will twist the question. They will remodify the question and ask it in the application based format. For example, a convex lens is used in projector and also in a camera. So using this idea, they may frame new questions. Okay, so here is the one question based on this application. I'll read out the question. In above image is that of digital single lens reflector, that means DSLR camera, which are used to take high resolution photograph by professional photographers. The second image of the above two is a schematic diagram of how an image is formed on the sensor of camera. Based on your understanding of the lenses, answer the following questions. Here they given four questions. So we'll solve one by one. So first question is, what type of the lens is used in DSLR camera shown in the image? If you see first image, so they given camera. So you see second one, that is ray diagram of camera. Okay, so outline of the camera. Here they mention one lens. What type of the lens it is? What kind of the lens it is? That is convex lens. Okay, so you already application of convex lens, right? Convex lens is used in DSLR cameras, slide projectors, overhead projectors. Yeah, for this and this question, your answer is convex lens. Second one, what type of the image is formed on the sensor? What type of the image you can see from this picture? The given tree picture, right? What type of the image? That is real and inverted. So your answer is real and inverted. Okay, let us move on to the next question. A photographer is using DSLR camera with the lens of focal length f is equal to 50 millimeter to take a close-up photograph of a small object. The lens projects an image onto the camera sensor that is located 60 millimeter behind the lens. Calculate the object distance, that is the distance between the object and the lens. In this problem, they given focal length, that is 50 millimeter, and image distance they given, that is 60 millimeter. 60 millimeter, the sensor is located behind the lens. So that means where image will form. By using lens formula, we can find out object distance. Write on lens formula 1 by f is equal to 1 by v minus 1 by u. Rewrite the formula because we are finding object distance, that is 1 by u is equal to 1 by v minus 1 by f. Substitute the values in the formula. V value is 60, f value is 50. So 1 by u is equal to 1 by 60 minus 1 by 50. Now take LCM for 60 and 50. LCM is 300. Then 1 by u is equal to 5 minus 6 divided by 300. 5 minus 6 is 1. Oh, sorry, minus 1. 1 by u is equal to minus 1 by 300. Then u value is minus 300 millimeter. Okay. Next, our question they given, that is D. A photographer is using DSLR camera to take a picture of flower. The flower is positioned 150 millimeter away from the camera lens. The actual height of the flower is 80 millimeter and the image height formed on the camera sensor is measured to be 20 millimeter. Calculate the focal length of the camera lens. So here they given three values. One is object distance. Flower is positioned, means flower is an object here, that is 150 millimeter. Height of the flower they given, that means object height of the object is 80 millimeter, and image of the flower, that means image distance is 20 millimeter. So here we should use magnification. So magnification formula, what is magnification formula? Ratio of height of the image by height of the object. So m is equal to hi by h naught. Here you substitute the values. Hi is equal to minus 20, h naught is 80. If you calculate, you will get 0.25 minus 0.25 millimeter. Again use magnification formula, m is equal to v by u, image distance by object distance. So rewrite the formula because we are finding image distance. V is equal to m into u. Magnification value is how much? Minus 0.25. Then image object distance is minus 150. Okay, by multiplying minus 0.25 into minus 150, we'll get 37.5 millimeter. This 37.5 millimeter is image distance. So we know magnification, we know image distance. In the numerical only they given object distance. By using this object distance and image distance, we can calculate focal length. So now use lens formula, 1 by f is equal to 1 by v minus 1 by u. Substitute the values. 1 by 37.5 is your image distance minus 1 divided by minus 150 is object distance. Okay, next step we will get 1 divided by 37.5 plus 1 divided by 150. So here they given 37.5. By multiplying with 4, we can make this 37.5 as 150. So multiply 4 with numerator and denominator, both denominator and numerator. Then 4 divided by 150 plus 1 divided by 150. Now LCM is 150. In numerator we'll get 4 plus 1. Denominator in denominator 150. So 4 plus 1 is 5 divided by 150. 1 by f is equal to 1 by 30. Then f becomes 30 millimeter. Hence focal length of the camera lens is 30 millimeter. I hope you all understand this answer. Okay. So the DSLR camera question and slide projector question which I explained in the last video are both very important for your board exam. Please practice these two questions. Now without wasting much time, let's move on to the next question. So our next question is, okay, Zarina worked as an apprentice in a factory where flashlights and solar cookers are made. She learned to make the circuits, the design of the light box and light concentrators of the solar cookers as well. She learned the use of lens in making all those tools. Based on your understanding of the lenses, answer the following questions. Here they given four questions. This is case based question. First question is, what kind of lenses are used in flashlights and light concentrators of solar cookers? So you know application of the lenses, right? So then tell me, what kind of lenses are used in flashlights and light concentrators of solar cookers? Okay, the answer is convex lens. Next question, give the reason for your choices in your answer for part A. So a convex lens is used in flashlight to produce parallel beam of light. As the bulb is placed at its focus, in solar cookers, the convex lens is used to convert sunlight to a single focal point to produce heat. So you should explain in both the cases. Flashlight, we are using convex lens because it produces parallel beam of lights. So in solar cookers means in concentrators also we are using convex lens because it will convert the sunlight to a single focal point to produce more heat. Okay, next question. An object is placed 40 cm away from the lens, which is normally used in solar cooker. The image formed is twice size of the object. Calculate the focal length of the lens. Okay, here they give an object distance, that is u is equal to minus 40 centimeter. Since lens is in a solar cooker is convex lens, it forms a real and inverted image. So image formed twice size of the object. So magnification is what for real image? Negative. real and inverted image, it is negative, that is m is equal to -2. Use magnification formula, m is equal to v by u. So magnification value we know that is twice of the image is nothing but -2. So substitute the values, m is equal to v by u, m value is -2, we have to find v value, image value, then u value minus 40 centimeter. Cross multiplication you do, -2 into -40 is plus 80 centimeter. So image distance is 80 centimeter. In next step, we have to calculate focal length. So using lens formula, 1 by f is equal to 1 by v minus 1 by u. You substitute v value and u value. Image distance and object distance values you substitute in the place of v and u. Then 1 by f is equal to 1 by 80 minus 1 by minus 40. So minus into minus becomes plus. Then next step we will get 1 by f is equal to 1 by 80 plus 1 by 40. Take LCM for 80 and 40. LCM is 80. In numerator what we will get? 1 plus 2. 1 by f is equal to 3 divided by 80. So take reciprocal. 1 by f is equal to 3 by 80. Then f becomes 80 by 3. So your answer is 80 by 3 centimeter. The focal length of the lens is 80 by 3 centimeter, or approximately 26.67 centimeter. Okay. So next, one more question they given R question. An object is placed 20 centimeter in front of lens which is used in flashlights. An image is formed 10 centimeter away from the lens on the same side as the object. Calculate the focal length of the lens. In this numerical, object distance is 20 centimeter. U is equal to minus 20 centimeter. The image is formed on the same side as the object. So, image distance is minus 10 centimeter. By using the lens formula, we can write 1 by f is equal to 1 by v minus 1 by u. Then substitute the values in the place of v and u. 1 by f is equal to 1 divided by minus 10 minus 1 divided by minus 20. Here minus and minus become plus. Then what we will get? 1 by f is equal to 1 divided by minus 10 plus 1 by 20. Take LCM for 10 and 20. Then LCM is 20. Then in numerator we will get minus 2 plus 1. Minus 2 plus 1 is minus 1. 1 by f is equal to minus 1 divided by 20. Take reciprocal. F is equal to minus 20 centimeter. The focal length of the lens is minus 20 centimeter. The focal length of the lens is minus 20 centimeter. It shows the lens is diverging lens, means concave lens. Okay, let us move on to the next question. This question from electricity chapter. They given circuit diagram. Here 2 voltmeters we can see and 3 resistors they given. The arrangement of the resistor shown in the above figure is connected to the battery. The power dissipated in the 100 ohm resistor is 81 watt. Calculate the current in the circuit, reading of voltmeter 2 and reading of voltmeter 1. So first we'll solve current in the circuit. They given power value, that is 81 watt, and resistor value they given 100 ohm. By using these two, we can find out current value. You know power formula, right? P is equal to I square R. So rewrite the formula, I square is equal to P by R. So now substitute the values. I square is equal to power value is 81, then resistance value is 100. So 81 divided by 100 is 0.81. I square is equal to 0.81. Take square root. I square becomes I, then square root of 0.81 gives 0.9 ampere. Current value is 0.9 ampere. We move on to next question. Second one, calculate the reading of voltmeter V2. So this voltmeter is connected across R1 and R2 resistor. So R1 resistor value is 25 ohm, R2 resistor value also 25 ohm. Now these two are connected in parallel, right? Use parallel combination formula. So 1 by Rp is equal to 1 by R1 plus 1 by R2. Substitute the values, 1 by 25 plus 1 by 25. LCM denominator is same. So LCM is 25. Then 1 by Rp is equal to 2 by 25. Take reciprocal, then Rp becomes 25 by 2. 25 by 2 is nothing but 12.5 ohm. By using this resistance value, we already got current value, right? So by using these two value, we can find out voltage of voltmeter, reading of voltmeter V2. V2 is equal to I into Rp. So I value is 0.9, R value is 12.5. If you calculate this one, 0.9 into 12.5 gives 11.25 volt.
The reading of voltmeter V2 is 11.25 volt. Okay, next, calculate the reading in voltmeter V1. So here, one voltmeter V1 is connected across 100 ohm resistor. Okay, so we know I value. Now by using this, we can find out V100. V100 is equal to I into R100. I value is 0.9. Resistance value we know, that is 100. So 0.9 is into 100 is 90 volt. By using this V100 and V2, we can find out voltmeter 1. Okay, voltmeter 1 is sum of V100 plus V2. So V100 is how much? That is 90 volt plus V2 is 11.25 volt. So now 90 plus 11.25 volt gives 101.25 volt. So reading of voltmeter V1 is 101.25 volt. I hope you all are understanding the numericals clearly. In the next class, I will focus on important 2 marks and 3 marks questions. Thank you everyone.